Professor Biswait. Today we will talk about discrete probability distributions, primarily the Poisson distribution. So let's go analyze the Poisson distribution formula. The first thing that we need to look at is the formula. If you look at it, it has some exponents and some parameters that I will explain what they are. So if you want to calculate the probability of X number of occurrences given some mean number of occurrences over a period of time, a volume of area, you use Poisson distribution. So it has both the lambda, which is the mean number of occurrences per unit, whatever that you're measuring, and X meaning the number of occurrences that you want to calculate the probability for. So as you see, this is somewhat of a clumsy formula. It takes a couple of steps to get it done. Now let's look at an example. We have an example of 200 topographical errors randomly distributed in a 500-page manuscript. So I want to find out the probability that a given page contains exactly 3 errors, 3 typos. So once you read the problem, you can actually identify what X is. X equals 3. What lambda is, that's the mean number. So how many errors did we have? 200 divided by 500, which is the approximate number of errors per page. So that's 0.4. So when you write your formula, P of 3 semicolon 0.4, that means you have to put e to the negative 0.4, which is lambda, times 0.4 to the third power divided by 3 factorial. So you can plug all that in and you'll get 0.0072. The beauty about this distribution is that you'll be able to use your calculator to do it, and it's all built in. And it comes from the Poisson PDF button, and I'll show you how that works. Now let's go to the calculator. I will have to go get the Poisson distribution from the distribution menu. For that, you have to click second distribution, and that is down at the bottom of this menu. Binomial is the first one, and then comes Poisson. So you pick Poisson. That is the C option. Then you have to first enter the lambda, the mean number. So the mean number was 0.4, so you're going to enter 0.4 and comma. And you'll enter how many things you want. We want 3 errors, so you are going to enter 3. And close the parentheses. All you have to do is just push enter. You'll get 0.00715, which is what we got before. Now let's go back and look at another example. This one is kind of similar, but let's assume that I'm looking at the same kind of manuscript, but this time I want to find the probability that a given page contains at most 3 errors. So how do you do this at most problem? So let's go to the formula. When you have at most 3 errors, that means you have X equals 3, lambda equals right before 0.4, but we're talking about 0 error in a page, 1 error, 2 errors, and 3 errors. So I'm supposed to go and add those errors up. So the probability of 0 error, plug in the formula, 1 error, plug in the formula, 2 errors, plug in the formula, and 3 errors, plug in the formula. And as you see, this became already a little bit too complicated. You have to go and calculate these, maybe store them in your calculator, and then add them up. When you do this, you get 0.999. But I'll show you how easy it gets when you use the Poisson distribution on your graphing calculator. So let's do that. When you look at your calculator, I will go and I'll get the Poisson button from the distribution again, second distribution. I'll scroll down. You will see that Poisson has 2 options. The first one is the PDF and the second one is the CDF. Since I'm doing the cumulative, so I'll have to pick the CDF button. So pick it by pushing enter. The first thing you enter is lambda, that's the mean number, 0.4, comma. And what do you want to add to that point? So I want to add up to 3, so I have to enter 3. And what the computer will do, it will go and calculate the 0 and a 1 and a 2 and a 3 and then add them all up. When you push enter, you see that I get the same number. So that's very, very quick compared to the one that you have to do by hand. Now let's do another problem where you have to change a couple of things, but not too much. It's kind of the same kind of problem, but this time you have the same manuscript, and this time I want to find out at least 3 errors. What is the probability that I will have at least 3 errors? So I may have 3 errors, 4 errors, 5 errors, all the way to 500 pages, and 200 typographical errors in 500 pages. So I have to go 3, 4, 5, up to 200 errors, and that takes a lot of steps. Or you can use the complement approach. You can say, okay, well, getting at least 3 errors is the same as 1 minus getting 0, 1, 2, 3. Since it's at least in here, so I'm not going to include the 3 in here, so you have to go up to 3. If it said at least 3 equals, if it said strictly at least 3, then you would have included it, but you don't at this point because you want to take out 0, 1, and 2. So you go 1 minus the probability of 0, probability of 1 error, and probability of 2 errors, and now you go and calculate those, plug it into your calculator, and get 0.008. You have to go and use that lengthy formula. Or you can do the same thing using your graphing calculator. So let's go to the calculator. So what I want to do is I want to subtract the probability of 0, 1, and 2 from 1. So to do that, you enter 1 minus, go get your distribution from distribution menu. You scroll down, and you see that the Poisson is the option D. Push enter. Now you're going to enter the lambda 0.4, comma, and you need to enter 2 because you want 0, 1, 2 taken out. Close the parentheses and push enter. And you'll be getting the same number, 0.0079, which is rolled up to 0.008. This concludes the module of explaining how you can use your graphing calculator to do calculations for the Poisson distribution. I showed you 3 examples. So make sure that you practice those examples, how the at least and at most problems work. And I'll see you next time.